Here I'm going to talk about the simultaneous equation method of overhead allocation and reapportionment. So under this method, a series of simultaneous equations are formulated after taking into consideration the overhead as per primary distribution and percentage of service received from other service departments. So now let us look at the problem which I have shared it to you. Now, if you look at the problem, we have two production department R and S and two service department, that is maintenance and power. So the primary allocation of overheads for R is 2 lakhs, for S it is 2 lakhs 3,000, for maintenance is 20,000, and for power it's 30,000. Then the service consumed or the service provided by the maintenance department to the other department, for R is 40%, for S it is 40%, and for power the maintenance is giving service to power department for 20%, and the service being provided by the power department, it goes 70% to production department R, 25% to production department S, and it gives 5% service to the maintenance department. So based on these information, you have to form an equation. So now if you look at the solution, it says let total maintenance department cost be M and total power department cost be P. Then the total overheads for maintenance will be M is equal to 20,000 plus the service which the maintenance receive from power, that is 5%. So it will come to 0.05 P. Then for service department P or power, the total overheads will be 30,000 plus the service being received by power from maintenance, that is 20% or 0.20 M. Now you substitute equation 2 in equation 1. So M will be 20,000 plus 0.05. Then instead of writing P, you substitute the value of P in the equation. So P is 30,000 plus 0.20 M. Then M is equal to 20,000 plus, how do we get that 1500? It is 0.05 into 30,000, we get 1,500. Then plus, how do we get that 0.01 M? That is 0.05 into 0.20 M will get 0.01 M. So if you take M on the left hand side, we'll get M minus 0.01 M is equal to 21,500, that is 20,000 plus 1,500. Then 1 M minus 0.01 M will get 0.99 M, which will again be equal to 21,500. Then M, you'll get a value of M by dividing the 21,500 by 0.99, which will come to rupees 21,770. Now you can substitute the value of M in equation 2. Equation 2 is P is equal to 30,000 plus 0.20 M. So instead of writing M, you substitute the value of M which we have calculated from the equation 1, that is 21,717. So 30,000 plus 0.20 into 21,717 will get 34,343. Then you have to do the distribution. So the departmental overhead or the primary allocation is 2 lakhs for R, 2 lakhs 50,000 for S, and for maintenance 20,000, and for power it's 30,000. So the total overhead cost is 5 lakhs. You take the total of all the 4 departments. Then you allocate the maintenance cost. Then while allocating the maintenance cost, we have to take according to the equation. So the total overhead cost of M is 21,717. So distribute that amount in the ratio of the service being provided by the maintenance department to the other department. So the ratio is 40% is to 40% is 20%. That is will be 2 is 2 is to 1. So if you distribute the amount 21,717 in the ratio of 2 is to 2 is to 1, we'll get 8,687 for R, 8,687 for S, and 4,343 for power. Then after that, you distribute the power the power overheads to all the others, other department, that is including the service department. So you take the amount, the total amount is 34,343 from the equation 2. Then you distribute this amount in the ratio of 70 is to 25 is to 5, that is the service being provided by the power department to the other department. So if you distribute the amount in the ratio of 20 is to 25 is to 5, or in the ratio of 14 is to 5 is to 1, you'll get 24,040 for production department R, 8,586 for S, and 1,717 for maintenance department. So the allocation has been made. So the total overheads for the production department is 2,32,727, and for department S is 2,67,273.